Okay, so let's start. So today we'll solve GET 2022 question from real analysis. So this is question number 38. What it is saying that let f be continuous functions on minus pi to pi such that fx is bigger than f0 by 2 for mod x less than delta for some delta in 0 to pi. And let us also define p and delta of x to be the 1 plus cos x minus cos delta whole to the power n for n belongs to natural number. Then 4 options are given. You have to check which one is or are correct. So these are the 4 options. Now, so in order to solving this is the NPTEL reference. Okay, now let's solve the question. So what it is given, f from minus pi to pi to r be continuous function such that fx is bigger than f0 by 2 for mod x is less than delta for delta between 0 to pi. So this is continuous functions in compact intervals, so therefore f is bounded. So therefore f is bounded. So f is bounded means, so mod of fx is less than some quantity c for all x in minus pi to pi. Okay, so we'll use this one, that f is bounded. So what you have to find, you have to find the 4 integral, right? So you have to find this 4 integral. So let us also first analyze what is p and delta. So p and delta of x is given by 1 plus cos x minus cos delta to the power n, where n is natural number. Now let's see what this functions is saying. Let me write down. So this is a graph of cos and in minus pi to pi. Let's say this is minus pi, this is pi, this is 0. Let's say this is delta, this is minus delta, right? So this is cos. So at 0 point this is 1. So note that cos A is decreasing in this interval. So note cos x is decreasing, cos s is decreasing on minus on both this side, on minus pi to 0 and 0 to pi also. So we'll use this one, that cos s is decreasing. So what will happen? So for 0 to pi, you have to check what is cos x minus delta. So for mod x, so when mod x is less than delta, when mod x is less than delta, then what will happen? So let's say positive part on 0 to pi means x is bigger than this, less than delta. So as cos is decreasing, so therefore cos x minus cos delta is positive, right? So this is positive because as delta is bigger than, so cos delta will be, so this is decreasing, so cos at the point x is bigger than cos delta on 0 to delta. So so Pn delta of x, so this is 1 plus cos x minus delta cos delta. So as this is bigger than 0, so 1 plus this will be strictly bigger than 1 for all n, right? So this quantity will be strictly bigger than 1 for all n. So in this side. So this is, let me say, so this is case 1. And case 2 is 1. So similarly for, so case 2, let me say, when mod x is less than delta on 0 to pi, on minus pi to 0. So means what is this range? So this range is basically minus delta less than x less than equals to 0. So again the same thing happened, right? Because cos is even function. So therefore we have this cos x minus cos delta is again positive, because in this range cos x is bigger than cos minus delta, right? So this is also positive on minus delta to 0. So therefore Pn delta of x, so this is 1 plus cos x minus delta cos delta to the power n, which is strictly bigger than n for all n belongs to natural number. Now case 3, when, so let's say when x is lying in this range bigger than delta and less than pi, positive x and which is bigger than delta. So let's delta less than x less than pi, right? So then what will happen? Then cos x minus delta cos x minus cos delta. So there, as x is, cos x is decreasing, so cos delta will be bigger, so this will be strictly less than 0 on delta to x. So what is this then saying? Pn delta of x, so this is 1 plus cos x minus cos delta to the power n. So as this quantity is strictly less than 0, so this is less than 1 for all n belongs to natural number. So this is the case 3, and similarly case 4. What is case 4? Case 4 is when x is lying between minus pi less than x less than minus delta. Then also cos x minus cos delta, which is again in this range cos is decreasing, so at the point delta it will be, value will be bigger, so this is strictly less than 0 on minus pi to delta minus delta. So Pn delta of x is 1 plus cos x minus cos delta to the power n, so this will be again less than 1 for all n belongs to natural number. So you have get these 4 cases. So using these 4 cases we will solve this question. So what is the first option? It is saying that limit n tends to infinity integration 0 to 2 delta fx Pn delta of x dx is 0. So let's check this one. So option A we are checking first. Limit n tends to infinity, integration 0 to 2 delta fx pn delta of x. You have to find that this is limit is 0 or not. So because we know it's so let's first divide this into 2. So let's write integration 0 to 2 delta will divide it into two part, fx pn delta of x dx 0 to delta fx pn of delta x dx plus delta to 2 delta fx pn delta of x dx. So let me call this is to be I1 I and this is 1 and this is 2. So you know what is the property of f? We know that fx is bigger than f0 in this region, right? So we'll use this one. So first let's check this one for I1. For I or 1 first do. So on this is the integration from 0 to delta on 0 to delta fx is bigger than f0 by 2, right? And what we also know that on 0 to delta, so this is the case 1, we know pn delta, so this is bigger than 1. Okay, and pn delta is bigger than 1, so this is positive. So therefore as pn delta of x which is bigger than 1 on this region, so you can multiply. So fx pn delta of x is bigger than f0 by 2 pn delta of x on 0 to delta. So now integrate both sides. Integrating both sides from 0 to delta, what will get 0 to delta fx pn delta x is bigger than 0 to delta f0 by 2 pn delta of x. Right, now let's take the limit n tends to infinity. So this is I, right? So this is the, I think no, I have not defined this. So limit n tends to infinity 0 to delta fx pn delta x dx. So this we have get limit n tends to infinity 0 to delta f0 by 2 pn delta x dx. f0 by 2, this is simply a constant, so you can take it out. And here you need one Pareto's lemma, that this limit you can take it inside. Okay, so here let me write. So this is simply because f0 by 2 is a constant. Limit n tends to infinity 0 to delta pn delta x dx. Right, now we'll use one lemma. Okay, so here we need one lemma, so let me write the lemma first. So this is called the Pareto's lemma. So what is this lemma saying? So let fn be a sequence of measurable functions, with fn to be non-negative, means positive measurable functions, if limit n tends to infinity fn x goes to some fx for all almost every x. So this is here we do not need, so let me write it in, so I am writing it in general. So then integral of fx, so which is, so what is the meaning of this? So this is limit n tends to infinity fn x, so this is dx is less than lim inf of integral fn x n tends to infinity dx. So it is saying that you can take out the limit from inside, but you have this inequality sign. Okay. So this we will use this. So here we will use this one. So therefore what we have, therefore so this one now also note that in this region what is p and delta, what is limit p and delta. So note that p and delta is positive, so this is the case one, because p and delta is bigger than 1, so this is positive, so you can apply this Fatwood's lemma. And so this is bigger than, this is the f0 by 2 limit n tends to infinity 0 to delta p and delta x. So by Fatwood's lemma here it will be bigger than equals to f0 by 2, so limit will goes inside, limit p and delta x, right. Here we have used by Fatwood's lemma. Now what is the limit of p and delta in this region? Note as p and delta x is strictly bigger than 1 for all any natural number, so limit n tends to infinity p and delta so basically it is look like this one, right? 1 plus cos x minus cos delta to the power n, and this quantity is strictly bigger than 1, right? And this quantity is strictly bigger than 1 for all n in natural number. So limit p and delta of x, so it will be infinity, because if to the power something x to the power n where x is bigger than 1, then the limit will goes to infinity, right? So that's why the limit is, so therefore what we have, so using this one, therefore limit n tends to infinity integration 0 to delta fx p and delta x dx, which is bigger than f0 by 2 limit 0 to delta limit n tends to infinity p and delta x dx, and this side goes to infinity, so this is goes to infinity, right? because, and this is, so this limit goes to infinity, so therefore this will diverge to infinity. So therefore, which is same as saying that limit n tends to infinity 0 to delta fx pn delta x dx. So this is infinity. So in 0 to delta we have got that this limit is infinity, and what is, so we have checked this first one that this is infinity. What is the now second one? Let's check this one. So this is the easier part. So for 2, what we have to find, this is from delta to 2 delta fx limit n tends to infinity fx pn delta fx x dx. You have to find, right? So now here we will, so that we can, here also we can interchange the limit with equality. So whenever we need to interchange the limit and integral, we need Fubini's theorem, right? So for that we have to check that integrand is absolutely integrable or not. So let's check this one. So claim, so let's first check. So for Fubini, using Fubini's theorem, we have to check that this is absolutely integrable. So let me, so for that we have to check that delta to 2 delta, so this quantity is absolutely integrable or not. So then this is less than, because fx, note that f is continuous, so f is bounded, that we have said earlier. So this is mod of fx times pn delta x dx. So this is c times, and what is pn delta? We know this is basically for delta, for pn delta is from delta to 2 delta, so this is false in this case. Delta to 2 delta, basically which one? This one, right? Case 3. Here it pn delta is less than 1. So use this one. So this, so then the integral become delta to 2 delta dx. So here we have using these two things, that mod of fx is less than c for all x in minus pi to pi, and pn delta x is strictly less than 1 on delta to 2 delta, right? So this is follows from the case 3. So what is this? So then basically this is saying that c times delta. So this is finite. So the integrand is, so 0 delta to 2 delta fx pn delta x dx is absolutely integrable. So therefore we can use Fubini's theorem. So by Fubini's theorem, so Fubini's you're saying that you can interchange the limit and integral if the integrand is absolutely integrable. So by Fubini's theorem, limit n tends to infinity delta to 2 delta fx pn delta x dx. So you can take the limit inside, limit n tends to infinity fx pn delta x dx. As f is n independent and the limit of pn delta, so what is limit of pn delta in delta to 2 delta? So again, as pn delta basically the inner function is less than 1, so not, p and delta x, so this is basically 1 plus cos x minus cos delta to the power n, and this one is, we have shown that this is less than 1, right, less than 0 in this region. So therefore limit n tends to infinity p and delta x, so this is 0, because this is entire, so let me write the entire quantity, it will become less than 1. So if you take n tends to infinity, it will goes to 0. So therefore this one, it is basically delta to 2 delta fx limit p and delta x dx, and limit of this quantity is 0, so over will get 0. So therefore what is final, we get limit n tends to infinity 0 to 2 delta fx p and delta x dx. So we have divided into two part, right? So this is first part and the second part. So first part we have seen that this one goes to infinity and second one goes to 0, so overall the integral become infinity. So the first option is, it is saying that it goes to 0, so this is not correct. And option B is similar, so let me tell how can you can do this. So this is similar. So option B, it is saying that limit n tends to infinity minus 2 delta to 0 fx p and delta x dx. And here this is similarly, because what you will do on my, so you will again write it into two part, limit n tends to infinity minus 2 delta to minus delta fx p and delta x dx plus limit n tends to infinity minus delta to 0 fx p and delta x dx. And again this part minus 0 minus delta to 0, so again similarly as a, one can show limit n tends to infinity, because p and delta in minus delta to 0, what you will go again this one, I think in the case 2 in minus delta to 0, so p and delta basically the integrand, let me write, then it will be clear for you. This is bigger than 1 and this is bigger than 1. Oh, sorry, yeah, this is less than 1 and also this is less than, because the inner quantity we need to be the less than 1, so that it will goes to 0. So for minus delta to 0, because this is bigger than 1 inside, so as limit n tends to infinity, again this will goes to infinity. So this part minus infinity to 0 part, this will again goes to infinity fx p and delta x dx, so this will again be infinity. And what happened to this part? And limit n tends to infinity minus 2 delta to minus delta fx p and delta x dx. And again in this part minus 2 delta to 2 delta by you can use for this one, I think the case 3 minus sorry, case 4 minus 2 delta to minus delta. Here it is strictly less than 1, so the limit will goes to 0. So again this one it will goes to 0, so it is 0. So therefore limit, the overall limit again it will be infinity. Limit n tends to infinity minus 2 delta to 0 fx pn delta x dx is infinity. So option B is again similar. And what happened to option D? Option C? Option C is basically the, again it is similar, minus delta to 0 and 0 to delta you can write. So option C, you have to find limit n tends to infinity minus delta to delta fx pn delta x dx. So what is this? So this you can write again into two part, limit n tends to infinity minus delta to 0 fx pn delta x dx plus limit n tends to infinity 0 to delta fx pn delta x. And this one I think in the part B we have shown that this is minus infinity, delta to 0 this is infinity, and from I think part A we have shown in 0 to delta I think, so this is again infinity. So in both, here the both part goes to infinity. So overall using part A and part B, right? So using part A and part B, so this is again goes to infinity. So part C is also done. And what is option D is saying? So option D is saying that limit n tends to infinity, integral from outside the interval minus delta to delta. So there we have to check the limit, right? So let me, so this you can deduce from the earlier. So the option D, so limit n tends to infinity, what is this, minus pi to pi minus delta to delta fx pn delta x dx, right? So again this you can divide into two part, limit n tends to infinity minus pi to minus delta fx pn delta x dx plus limit n tends to infinity delta to pi, right? fx pn delta x dx. So minus pi to minus delta I think by A we have done. So this is similarly as this case, minus 2 delta to minus delta case. Similarly as minus 2 delta to 2 delta fx pn delta x dx we get, because in this whole range minus pi to minus delta limit n tends to infinity fx pn delta x dx. Here pn delta basically the 1 plus cos x minus cos delta is less than 1, so limit will goes to 0. So therefore we will get this to be 0. And similarly as I think from delta to 2 delta range fx pn delta x dx we get limit n tends to infinity delta to 2 pi fx pn delta f x dx, this is again 0. These two we can check by similarly. So therefore what we have get, so therefore minus pi to pi minus delta to delta limit n tends to infinity fx pn delta x dx. So because both the part goes to 0, so overall integral will be 0. So this is, so what we have get that option A. So option A is not correct because from we have shown from 0 to delta range it is infinite, so option A is false. Option B again is false because minus delta to 0 this is again infinite. Option C is again false because minus delta to delta this is again goes to infinity. And option D is correct because here it is outside the interval minus delta to delta where the p and delta goes to 0. So therefore the whole integral goes to 0 just by Fubini or something, because that we have done. So option D is correct. Okay.